everybody this morning? Doing all right, I hope? Good. This is the last week of classes. My, how quickly it has gone, huh? Seems like only yesterday when we were first learning the tender fundamentals of programming, and now we're on to bigger and brighter things, and soon you will have left my charge off to go program out in the wild, to do things, to achieve things, to do great things in the world. At any rate. Any questions about anything, including the exam? This is probably the biggest crowd I'm going to have all week, so, questions?
Can I just ask how many questions there are, like, relative to, like, the marking, and, like, how many marks there are in questions like that?
I generally don't divulge specific details like how many questions there are, how many marks they're worth prior to the exam. I don't think it's really useful information for people to have. Suffice to say that regardless how many questions there are, they have been measured and timed so that you're expected to complete X amount of work evenly throughout the duration of the exam. So, any other questions?
It's 2.5 hours.
Yes, 2.5 hours, yeah. Because it's an exam. Any other questions? Yes.
How fast are the TAs doing?
We haven't had TAs write it yet, but generally the thing I'm shooting for them is to have achieved it in something like 45 minutes. So if you take that and you multiply it out, it's like 40, 45 minutes. If you take that and multiply it out 3 times, then you get a pretty good writing time, in theory at least. Any other questions? None? Oh, question at the back? No? Just, okay. Yes.
So everything up until this topic is tested, right? Like just SQL, like up to SQL, right?
In terms of coverage, it's everything excluding the topic on visualization. So you don't have to worry about the graphing, but all the rest of it is fair game for the exam, with the exclusion of machine learning, which is a thing that we're going to be talking about probably today. This isn't going to take us this entire class. So what I normally do is on or around the last class that we have, I usually have a review session where I ask the students to bring me problems that they've had, that they've solved on the board throughout the course. Any topic is any topic is fair game, and with the intention, to bring the problems that you foresee you might have on the final exam, so that you can see it solved by someone who hypothetically knows what he's doing. So that's what we will have tomorrow, because I think that I can get, a solid 3 hours out of the machine learning material, but no more than that. So, we'll probably have an hour and a half at the end of class tomorrow, during which we can do some problems. However, if you guys don't give me any problems, then I don't have any problems to do. So it's going to be important that you guys come at least a little bit prepared to that class with problems that you'd like to see. Okay? Are there any other questions? Yes?
Assignment 4 marks haven't been released, right?
I'm not sure. I can check. I don't think I heard anything about it. If they're not released, I'll poke Sarth and see what the holdup is. they're just not going to work. Okay. I'll check. I'll follow up on the status of assignment 4 grades once class is finished. An email to remind me never goes amiss because I often forget things. Are there any other questions? Assignment 5 is due today, I believe. It was extended to today, so we can't extend it any further than that because of, there might still yet be people who haven't used their MSAF. So, it is correct and proper that the assignment should be due before the exam, so it goes. We've been booked for the same room for the exam that we had for the midterm, so y'all should know where to go. And yeah, it'll be even more comical because we'll probably only have, probably only 25 people come for a room that seats 400. So, we'll just make you so sparse in the room that we still get our exercise in running from person to person. But anyway, question?
Are there only 25 people left in the class?
There are, at last I counted, 29 people left in the class, but normally, generally speaking, like 10-15% of people just don't do any particular thing. Like, these are people who registered in the course but never bothered withdrawing, sort of thing. You can write off about 10% of any class that way. But, yeah. So it goes. Any other questions? Okay. Shall we get into the stuff? We were talking about SQL. So Mark contacted me over the weekend and asked me to make it very, 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 very explicit and clear to you guys as I'm teaching you databasing that SQL is not Python. It is not executable by the Python compiler directly. Taking SQL queries and simply entering them into a box inside of a Jupyter notebook is going to result in, minimally syntax errors. SQL is a completely different language from Python. It operates with a completely different compiler/interface system. And, I know that, a lot of you will be very new to the world of computing, but you can't just, take code from any old language, load it into a Python compiler and expect it to work. So, the question then becomes, how do we interact with a database, an SQLite 3 database, from Python? Because it is possible, right? It's just not, you can't just enter the query directly. That's not how things work, right? So, the process is reasonably similar to how one interacts with a CSV file. The process of opening the file and doing stuff to the file and then closing the file still applies when we're talking about databases. The wording is slightly different on the methods that you're using. You don't use the open command, for instance. But so long as you have some type of quick reference for what the specific commands are in this particular instance, there should be no, there's no conceptual difference there are some minor conceptual differences, but in general, the procedure is much the same as the procedure we have been studying so far. So, let me call up my example file, and we will do a live demonstration. So, if you recall, we had our video store.db database file. This was the example that we were constructing last time in class. I can interact with this directly using the SQLite3 command interface. SQLite3. If you're a Windows user, if you recall from the last lecture where I showed you where to download the SQLite tools, if you execute SQLite3.exe, you will get a terminal window that looks very similar to this, and it's probably one of the few times you've seen such a terminal window inside of Windows, unless you like fooling around with network configurations and that sort of thing. So, again, this is not Python. So, you can interact with the database file from the SQLite3 interface. I can open the videostore.db, right? I can select star from movies, for example, and all my movies are there. So far, so good. Let's see if we can get that working in Python. So, do I have a file started for this? Doesn't seem like I do. All right. Get it. SQLite stuff.py. So, of course, insofar as it was convenient to use the CSV library for parsing CSV files, downright essential to use the JSON library to parse JSONs, and YAML is in the same category. Importing SQLite3 here does way more even than importing the JSON library to be able to parse JSONs. You could, in theory, still write a parser that extracts information from JSON files without actually using the JSON library, although it would probably take, a reasonable amount of development effort. You're probably looking at, a week of trying to reconstruct a library. In order to reconstruct this library, you're not replacing a simple parser of a file in this case, you're replacing a compiler, which, would probably take years of development effort in order to reproduce the function here. So, not all libraries are created equally. Some do a lot more than others, and this is one of the ones that does quite a lot. So, bottom line, if you're asked to work with databases on something like the final exam, your first step is to import SQLite3. Subsequent to that, we need to open the file. So this is not couched in the language of opening up files. This is couched more in like network language. So rather than opening the file, we are connecting to the database, right? So from the SQLite3 library, we use the connect method. This connect method returns something resembling a file handle, but has details that are different from a file handle. Fortunately, it's not important for you to know the difference between this and a real file handle. Suffice to say, this is an SQLite3 database object, which has certain properties, but in all, behaves quite similarly to a file handle. So, of course, the database object is the return result of the connect method. We must therefore capture it in a variable, because that is how Python do. So let's take a look at this. Import SQLite3 database is equal to SQLite3.connect, and then you provide your file name. Videostore.db. Notice in this case unlike with the open function, we do not have to specify whether this is in read or write mode. The concept of reading and writing is embedded in the queries that you will be providing to the database, right? If you create an insert command, that automatically becomes a write operation. And when you use a select command, that automatically becomes a read operation. So it's embedded in the commands that you provided themselves, rather than any jiggery-pokery to do with the original invocation of the method that opens the database. You guys following so far? Good. So, similarly to files, and perhaps somewhat more strongly than files, when you connect to a database file, the operating system places a lock on that file so that other programs can't simultaneously open it. Therefore, it is highly important that when you're finished with the database, you close it, because the act of closing the file is returning to the operating system control of that file so that another program can open it. This is generally called a mutex, although that's not a word that you're likely to hear again for a few years if you choose to continue doing computer science courses. So, good. As one might expect, certain SQL data types have direct interpretations in terms of Python data types. Some of them are as you would imagine. Integers, reals, and texts all are directly integers, floats, and strings respectively. The null type in SQL becomes the none type in Python, so the none object, which we've seen a few times before. The Boolean type also becomes Boolean, although it does not appear in this chart. But most interestingly, the date data type is interpreted as a string, not directly as a Python datetime object. If you want to use Python's datetime objects, you must use a particular method in order to parse that date string according to its format, and from that you can extract a Python datetime object. The name of that method is strp time, as you might recall from last week. Good. Any questions? So, although we have connected to the database, the next thing that we need to do, because basically we just have the database open, right? The way that SQL works is it must have an open session where through which commands can be sent. So it requires what's called a cursor. So the cursor that you're opening here is essentially the same thing as the command prompt that you have in the terminal display, right? If I were to open up SQLite 3, this guy right here, this blinking box, that is called the cursor, which is kind of an old term for it, but this is an old language. So this is the cursor. When you instantiate a cursor in Python, what you're essentially doing is you're creating one of these guys through which commands may be entered. It functions, the cursor in Python functions as closely to this command prompt as is possible inside of a script. So, that's the reason that I even showed you the command prompt interface at all, in the first place. Because once you have opened up the cursor, you're essentially dealing with one of these anyways. And this is, the same as this, but without a lot of the trimmings and trappings, and a little bit more interactive, so better for the purposes of demonstration. So, and I was kind of saying that more to Mark than anybody else, but anyway. So, what we have to do is we have to open up a cursor. CUR is equal to database.cursor. So you create a cursor object by invoking the cursor method of the generated database object. From there, SQL commands can be transmitted to the database using the execute method. The SQL command itself is encoded as a string and provided as an argument to that method. These strings may be any of the SQL commands that we have dealt with so far. You have the full expressivity of SQL as a language going on right here. Incidentally, as we're going to see in a couple of slides, you have not only an execute command, but you also have an execute all command, which is designed for executing multiple statements. As we're going to see, the execute command is generally considered safer. And safety is something that you actually have to worry about with SQL databases. Unlike most of the time where people just kind of ignore it. But anyway, so because this method is designed to process one command only, whether or not you include the semicolon character is up to you. It can be included, but it doesn't have to be included. The purpose of the semicolon character is to designate the end of a command. Because this is accepting only one command anyways, there you go. I'll probably when I think. At any rate, if we want to view everything in the database that we're connecting to in a particular table, cursor.execute, select star from movies. There we go. There we go. Okay. I'm recapping some stuff that I was doing last week. But that's okay, because there's not a great deal of overlap between the people who were in that class and people who are in this one. I think just you. Hopefully you don't mind us going through this. But this stuff is going to be pretty important, so perhaps it bears repeating. So, there we go. So, when I execute SQLite3stuff.py, which is the file I'm working on over here, I get precisely nothing output. This shouldn't be much of a surprise, because we have done nothing to print the results of this command being executed. The question becomes, where are the results of this stored? Right? Because we have connected to the database, we have sent it a query requesting results. Where have those results ended up? Well, there are a couple of ways that you can go about it. The first way is to extract it from the cursor object itself using the fetch instructions. You can either fetch one or fetch all. So if you print cursor dot fetch one, that fetches one. If you select cursor dot fetch all, that gets all of the database entries. Notice, if you're fetching one, you get the results in the form of a tuple. If you fetch all, you get the results in the form of a list of tuples. So there you go. We have loaded data from the database into Python. From here, you can use all of your regular methods of processing to do whatever it is that you want to these values. Note, however, this is not a string. When we were connecting to CSV files and we were reading numbers out of them, we required explicit conversion to integers or floats or booleans or whatever data type it was that you were using other than string. In this particular way of going about it, using databases, the data types are known by SQLite 3. Therefore, the correct data type is inserted when you read it into Python. So you don't have to worry about explicit conversion, which is kind of handy. Any questions? Yes, sir.
Okay, so when you're importing SQLite 3, are we writing Python commands or for SQL, or are we writing SQL commands?
When you are sending commands to SQLite 3, it must be SQL commands. Python understands Python. SQLite understands SQL. They don't understand each other, right? Mm-hmm. What this is doing is it's simulating the command line environment which I was able to pull up SQLite 3 in. Now, once you get on in, should you choose to study computer engineering further, you'll find that pretty much any general purpose programming language can invoke other programs the same way as a command prompt or anything else. Programs can run other programs. This is an instance where Python, a program, is running SQLite 3, another program, providing it inputs, but it has to provide inputs in a manner that SQLite 3 will understand, which is why SQLite 3 commands are being given. Now, there is a certain amount of overlap between the two, right? The Boolean expressions, which are used to filter results, look very similar in SQL to how they look in Python. But, that's because, Boolean commands are very simple and are shared by many, many programming languages, not just these. So, it's kind of like observing that Boolean expressions are being used in both places is kind of like observing that letters are being used in both places, right? It's like, well, yes, it kind of comes with the territory. Does that answer your question?
Yeah.
Yeah, any other questions?
One more. So you wrote the command select star from movies. So you said that is like it performs in a single command, the execute thing, right? The curve.
Yes.
Let's say, so if we want like multiple commands, do we have to write it multiple times or in one line?
There are two ways of going about it. You can repeatedly use the execute method. There is also an execute all method, which allows running multiple statements. it's not as safe for reasons that we're going to see.
Okay.
But, so this is the preferred method. But it is possible to do multiple commands in one go. So I'd like to illustrate this on the board. Just, perhaps for our television audience at home. So let's say we have the operating system, right? The operating system is a collection of programs that are all running, right? The operating system interacts with a thing called the kernel, which itself directly interfaces with the computer's hardware. On top of the operating system, you have what are called user programs. Right? So, user programs are anything like, basically any window that I've got open is a user program, right? Although, the terminals are technically shells, which are, somewhere between a user program and an operating system. But when I'm running Python, right, how this actually works is I've got the Python program, right? I slot into it the Python script which I have written, say myscript.py, right? What's going on with the with this SQL interaction is this. You've got another container called SQLite, right? What happens is your myscript.py starts an instance running of SQLite. It then requests SQLite to go open the particular database file, right? So SQLite goes into the file system, goes into the file system, finds the file, pulls it in, slots it into itself, video store.db, and now it's just quietly running in the background, right? It sends like it'll send a acknowledgement back to my script to say, I have successfully completed the operation you've requested. Otherwise, you would get an error in Python, like a file not found error or something like that. Good. Good so far as it goes. When we invoke the execute command, that again communicates with the SQLite layer that's wrapped around the open database, right? So, if you enter your select query, that gets sent to SQLite 3. Now, it gets sent to SQLite 3 in the same way if I had a command prompt, right? And I entered the select command on the command prompt. It's the same way that this program would send the command to SQLite 3. It's using the same input mechanism with respect to SQLite 3. That's why the commands that you enter with the command prompt and from Python are precisely and exactly the same in both cases, right? They're both using the same means of input. And when SQLite processes the command, anything it sends back is routed, to whoever sent that request. Does that make sense? This is kind of like how programs work. But very, very, very important. Again, I know I'm stressing this a lot today. There is a big, big difference between the Python process, which is running, and the SQLite process, which is running, which Python has opened. It's, it's like literally the difference between your internet browser and your solitaire program, right? That's like, they are completely separate and distinct programs, and they do different things. Does that make sense? Any questions? Good. So, so that's method one of getting information out of the cursor object's request. The other method is to understand that the return results of this method will also be the results that you're looking for. Now, when you have return results from a method and you want to capture them, you capture them in a variable. So we might say x or return value, retval, return value, something like that. We can then print the return value, see what we get. This also returns a cursor object. Question?
No, I just said that you get the address.
Yes. We're trying to print an object again, right? So in order to actually see the stuff inside there, what we can do is we can for loop over it. This object has a definition for iterable. So for entry in retval, print entry. There are all our entries. Just like that. Make sense? Any questions? Good? Good. So, you may note that when we receive our data from the database, we receive it as a set of tuples, or a list of tuples, or just a series of tuples, with no particular indication as to what the individual elements of that type tuple might actually mean. Since databases, with databases, it's required that each field has a name. We can do something similar to using the CSV dict reader to create a series of dictionaries rather than a tuple. So, it's quite simple. All you have to do is add the row, or add the line, database.rowFactory is equal to SQLite3.row. We execute the game, and let's just cast this as a dictionary. There you go. It behaves like a dictionary, so. Essentially, row factory is someone's cute name for a thing that processes rows somewhat more efficiently. What we're doing, row factory is a field within the database object. We set that to the row, the definition of row, which is provided by SQLite3. So it knows to look for rows in order to produce this material here. It's all very convoluted and mysterious. All you really need to know is that the end effect is that you produce a series of dictionaries or mappings rather than a series of tuples, which may be slightly more efficient to use because, you know, you can then access the information in the database the same way that you would access the information in inside of the database itself, using the field names rather than positional placement within the tuple. Make sense? Good. So, now that we have talked about reading information from the database, let's talk about writing information to the database. So let's imagine that we had another entry that we wanted to make. Say we wanted to add Beauty and the Beast, which is an animation musical comedy, rated G for garbage, and we wanted to give it a movie ID of 17. The way that you do this safely is slightly different from how you might expect to do this. So, let's say M is, well, you know what, I'm not going to assign it to a bunch of variables. Cursor.execute. Insert into movies, values, and then you literally provide a list of question marks with spaces. Then, as the second argument to the execute method itself, you provide a tuple that contains all of the information that you want inserted at the point of the question marks in the order in which it is to be inserted. So, in this case, 17, Beauty and the Beast, animation, musical comedy, and rated G. There we go. So, let's just demonstrate that this works. Execute, and you'll see the results of the select command now include one more entry, Beauty and the Beast. So this has worked. Furthermore, if we open this up in SQLite 3 using command prompt, videos store.db, select star from movies, you'll see, we need to actually save the database. So there's one further step here. We have to commit this database. We have to save it, right? So database.commit. Let's run this guy again. And there we go. Beauty and the Beast appears. Now, I'd just like to point out that there is an error in the slides. So everybody make a note of this. It's not cursor.commit, it's database.commit. It's the database that you're saving for, commit is it's a database operation. It's not a command that you're entering. So it's not going through the cursor, it's going through the database object itself. That is a mistake that is right there. So just keep that in mind. Good. So what we have not done here, taken all of these numbers and strings and spliced them into the string ourselves, right? Rather than, just say, end this string here plus GE or plus T and then open the string back up again to include comma, right? Rather than use concatenation to do this, we are using something more similar to the format method to insert information into the string where we have included a specific character which serves as a placeholder for the information we are inserting. There is a very good reason that we are doing it that way, which we shall see soon. But first we're going to talk a little bit more about relationships between tables, not between people. So, so far, we've only really talked about one table, right? We've been learning how to manage the movies table without really making reference to the other two tables that we said we would need for this whole shebang. Recall that we wanted a database of movies, we wanted a database of customers, and we wanted a database of who currently has which movie rented, right? So we'll want to add databases to keep track, or we want to add database tables to keep track of each customer and track the relationships between customers and movies. So let's create a new table. Create table customers. The schema that we will provide, we have customer ID, name and address. Number, primary key, text required, and address, which is also text but not required, because, not everybody has an address, and it would be overly discriminatory, I guess, to prevent the homeless from renting your videos, even though they can't be reasonably expected to have a VHS player because they have nowhere to put one. Anyway, so customer ID is an integer, primary key. Name is text and required, and address is text. Although I suppose this is discriminatory against the unnamed. So, so far so good. I'm just going to insert a few entries into this so that we have some data to work with. Insert into customers, values, 101, in case you were wondering, data entry sucks. Ah. There we go. It's actually St. Charles Place in Monopoly. All right, so select star from customers, and you can see all of our data appears. Boom. Good. So now we have 2 tables. Now, let us continue to create the rentals table. So, the rentals table is going to have 4 fields. We need a customer ID and a movie ID, both of which are required in order for a rental to exist. We need a date rented, and we need a date due. As you can see, these are very short-term rentals, but you know, it is what it is. So, create table, rentals, customer ID, integer, required, movie ID, integer,
Professor?
yes,
Right now you're writing this in SQL, right?
yes.
Okay.
You can tell it's SQL because it has semicolons at the end of each line. The structure of the command, of the SQL command, is very different from that of the Python file. Yeah. Not to mention, you can tell that this is SQLite because the command prompt actually contains SQLite, the word. I can also, I showed you a couple of instances of it at the beginning of the class, but you can get a similar thing for Python by just invoking Python 3 with no argument or not running a file. You know, you can also get this triple caret command prompt, which is the Python command prompt, where you can enter lines of Python code and have them executed directly. Same idea, but here with SQLite 3. So, there we go. So we have created the rentals table. Let's just insert into rentals values 103, 104. No. There we go. 3, 12, 20, 22. Why not? Update the date. 15, 2022. There we go. Then we'll say customer, this has also rented that. There we go. So now we select star from rentals. You can see that we have successfully entered the data. So, good. So this is just like a small taste of the power that these databases actually have, right? So, up to now, we haven't really been using these things for anything that you couldn't use a spreadsheet for, right? In relational databases, like the reason that we give the database the term relational databases is that they can be used to establish relations between tables. This using what's called the join or inner join operation. So essentially the problem here so we have this table of rentals, right? We have customer IDs, we have movie IDs. Fine, good, insofar as it goes. What if you want to, for example, see the names of all of the customers who had overdue movies? Which you might, like, that would be a totally practical thing that you might want to view, right? Are you going to get that information from just this table?
No.
No. you would have to cross-reference the movie ID with the other table in order to get that information. Cross-referencing takes time, it's boring, and nobody wants to do it. We can actually get SQL to cross-reference the table for us. That is the purpose of the join command. So, this is what we do. Rather than selecting from one table, we select from multiple tables. So, for example, if I wanted to cross-reference information, cross-reference, say, the customer ID with the customer name, you would say select star from rentals comma customers, where customers dot customer ID is equal to rentals dot customer ID. And there you go. So what this has done is it has created a series of entries where essentially we have every line in the rentals table appended with the cross-referenced information from the customers table. So I'll go into the structure of how this works a little bit because it's an expand and filter method, right? So what happens if I just remove the condition? If I remove the filter, what do we get? A lot of information. Note that for each entry in the rentals table, we have appended once every entry from the customers table, right? So it's like a multiplication, right? It's like, if I have 3 things and 3 things, how many different combinations of things do I have, right? It's like, these are combinations, and these are combinations, right? That's what it's doing. Question?
Like a permutation and combination?
It's, yeah, it's more like combinations than permutations.
Okay.
Yeah. Basically, this list is the set of all ways that items in the two lists can be combined, right? From here, we can now establish what the where clause is doing, right? First of all, note that inside of the where clause, we're using dot notation to access the individual field of the table. So customers.customer ID is this one, right? That's the rental table. Customers.customer ID is this column right here, right? Rentals.customer ID is the first column here, right? So you'll notice that for some of these entries, the customer ID matches the customer ID here, right? That match constitutes a correct cross-reference. So when we are constructing the query, we are filtering it for only those entries where the customer ID here matches the customer ID here. That is the same thing as matching up the customer to the rental, right? So that's what happens when you filter that list for only instances where the customer IDs match. Does that make sense? So, further to that, if you want to be a little more specific about it, you can also say something like customer.name, select customer.name and rentals.customer date due. Oh, what? What's it called then? Customer name?
It's just
Should be name. Oh, maybe customers, yeah. There we go. So, by further filtering this table for that information which is relevant to your search, right? You can, for example, get only the list of people that have movies that are due and the dates that they're due on. Now, if date was stored in some kind of more convenient format, like a numeric format, the problem with storing date as text is that you don't get to do like a greater than, less than operation on it, right? Which is how you would compare it to like the present date to see if the movie was overdue, right? That's one way you would do it. So it's a little bit more difficult to work with as text than, you know, for example, if you had like day, month, and year all as integer fields inside of the database separately, right? That would allow you to, you know, you could write up it would have to be pretty complex because you'd have to take into account like days in the month and, you know, that sort of thing is probably better done. Import into Python, convert things to a datetime object, and then use the comparison, right? That would be easier. But, you know, you could do it, right? You can see automatically who's got an overdue movie, right? This is much easier to read than that. That is much easier to read than this, and this is easier to read than having it spread across multiple tables. So, yes, question?
Could you just go up or a bit? Like I'm confused. What did, like, okay, it says customers.customer ID equals rentals.customer ID.
Yes.
But you use the same thing above as well.
Not here. I left off the where clause. I left off the filter.
Oh, so from, okay, select from rental. Okay, so that gives us all the combinations.
Yes, all the combinations, the raw output.
And then that, when we use where, it gives us the direct. Okay.
Yes.
So the same ID one.
Exactly. Precisely. Yes. 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 Very good. Yeah, and now we can, you know, we can even apply the next one, right? Let's say we were interested in not just who's got a movie who's got movies and when are they due, but what are those movies, right? So what you would do, let's say add movies.title, right? Then we select from rentals, customers, and movies where, oh, there we go, sorry, where customers.customer ID is equal to rentals.customer ID and rentals.movie ID is equal to movies.movie ID. So there we go. Now you'll notice we only get one entry. The reason for that, these movie IDs do not exist in the movie table. So it's looking for ones that don't exist, because if they don't exist, they aren't found, and because they aren't found, they aren't being printed.
But if they did all three work, happy.
Yeah, like if I added an entry for 107, then it would show up. Yeah.
Okay,
Yeah. Yeah, but just to illustrate the point, if I removed the filter here, right? Oh, I removed too much. I'll just remove the where, replace it with movies, and then there we go. And let me just remove this as well. Select star. You can see that for every entry in movies table. We have every possible combination with the customers. For every one of these two guys, we have each combination with the movies table represented.
Got it.
So you can see how this explodes in complexity, right?
So now you have 3,
Yeah,
and now they're like multiplying with each other, right?
precisely.
Got it.
Yeah. Which, you know, insofar as it was hard to get any useful information out of it before, you know, just about impossible now. Not to mention, these are exceedingly small databases, right? These are databases that I was able to, you know, whip up for you right here on the spot, you know? And, like, imagine how bad this would be if you were comparing, you know, like a real video rental store might have 10,000 movies,
Yeah.
right?
Yeah.
And maybe 1,000 customers,
Mm-hmm.
right? So you're looking at 10 million entries if you're just doing that, right? Now, like the thing that we're leveraging here is the fact that computers can process things very, very quickly, right? Like a computer might take a little bit of time to process your database query, but like relative to you finding it yourself, you know, there really strongly becomes a point at which a person who knows SQL, who's working with an SQL database, can find information in that database at like orders of magnitude faster than someone who's just looking through a a spreadsheet, right? Even with the find operation. So yeah, databases. Cool. Any other questions? All right. So, good. Good. So, this is called a join operation, or an inner join operation. And I've covered pretty much everything in these slides about it. So what we're going to have now is we're going to have a quick fire operation round. There's a lot of sort of small operations that are very useful that you should know about. If you pretend to know SQL on your resume, you should know about these. So, number 1, update, which allows you to change entries. The update command allows you to modify the values of existing entries in your table. You know, up to now, if you made a mistake, you had to delete the whole table, but not anymore. So, update, select the table, set field equal to the value you want, and rating equal to the, you have a comma separated list of the replacements you want to make, right? These will overwrite the existing values. And then, most importantly, you also include filter. This query will overwrite genre and rating for all entries that match the query in the same way that select matches the query, right? So, here we've said title is equal to Monsters Incorporated. So we are setting Monsters Incorporated to an R-rated horror movie, which is slightly amusing. If we were to leave this line out, every entry would get overwritten horror rated R, which would eliminate a lot of interesting and useful information in such a manner that it would take time and dedication to reconstitute the database that you just damaged. Not using the where clause constitutes vandalism. That's all I'm going to say. So, very important. This is not quite true. It depends on what database software you're using. Sometimes SQLite databases have undo buttons or reverse previous command buttons. It gets a little tricky with when you have multiple users, right? if there are lots of people all accessing a database simultaneously and you hit undo, whose work gets undone, right? What's the last entry, you know? So generally, it's like Linux and some programming languages have this general attitude of like, read the manual, and if you shoot yourself in the foot, don't come crying to me. And that's kind of the attitude that SQL takes as well. So, sometimes you can reverse something, sometimes you can't. One of the things that's often done is periodically the state of the database will be saved. It's kind of like an autosave feature. Some databases will have this, some won't. SQLite 3 does not. So it's not like your data would be completely irrecoverable, but you know, it's always a good idea to back things up before you do anything major. But yeah, question.
So let's say we're doing the assignment or something, and we made an error, and we use it. So can we change it like normally, just by just changing it, or do we have to use it?
So normally, like if it were an assignment or an exam or some kind of question like that, we generally provide you with some code that will regenerate the database that we ask you to work on, because we understand that when you're working on a database, you might screw the database up, right? So yeah, normally it's either one of two things, right? We either give you code that reproduces the database you're working on, or we say, well, you can always re-download the file from Avenue, right? At any rate, we will always make sure that you can get a fresh copy that sets you back to, to start, yeah. In fact, sometimes it's a good idea to take the file that you get initially, make a copy of it, and then, if you need it, then you don't have to go on Avenue. So, delete. Delete from table where condition. Deletes entries from the database, opposite of the insert command. In the same way that you have to be careful with the update command, you have to be careful with the delete command. It also expects a condition, and if none is provided, it will delete everything. So that's, so far as it goes. And finally, yeah, we have drop table. This is the atomic bomb of database operations. It just simply deletes a table and everything in it with no undo function. It is the nuclear option. Question?
What is the difference between delete from movies and nowhere and this?
So delete from movies will, and not having a where, will leave you with the table. So you won't have to re-enter the schema, right? It just deletes every entry from it.
Oh, so the table still exists but no data.
Exactly, yeah. So
this just kaboom.
Kaboom, yeah. Yeah, good questions. Any other questions? Good. All right. So let's examine a use case now. Let's imagine that we had a Python script going. We wanted some degree of interaction with the user. Let's say we wanted to design a Python script so that the user was prompted which rating they would like movies of which rating would you like to see. They provide input, right? And enter a rating you'd like to search for, that you store the result that they ask, that they return to you. How do you then connect that into the database? The naive approach is what you see illustrated here. We just have select star from movies where rating is equal to, and then you splice in the rating as provided by the user using simple string concatenation. Note, this is not the question mark method that we were talking about earlier, that I foreshadowed, was the only correct way of doing this, right? But this will work, right? If we enter in something like PG, right? PG will get inserted there. You have a complete and correct query. So, here's a question. What happens if our query what happens if the information entered by the user contains an illegal character, such as a quotation mark? So let's say they want to be sarcastic, and they say, the type of movie I want to see is parental guidance, right? So guidance is in quotation marks. When it gets spliced into this string, what we get is select star from movies where rating is equal to parental in quotation marks, guidance, and then a double set of quotation marks here, right? So because of the way that quotes work, parental is in quotes, there's an empty string here, guidance is considered a keyword, a command in SQL, because it's not inside quotes, right? So this is not a valid SQL query, right? You'll get an error. But the situation is much worse than this, because what this essentially gives the user the ability to do is enter commands from up here, right? The whole point of this program is to prevent the user from being able to enter direct SQL commands, right? Because maybe you don't trust them, right? Maybe this is like internet random people, right? You don't necessarily trust these people. That's why you're trying to protect your data from them, right? So, question. How about this little bugger? PG or x is equal to x, and you leave off the quotes on either side. When you splice that in, you get select star from movies where rating is equal to PG or x is equal to x. X is equal to x is always true. True or anything is always true. So, rather than view a movie of a particular rating, you get to see all the movies, which is a violation of what you were going for with this program, right? The user, by being clever and understanding that you're using SQL in the back end, has been able to access more information than they're allowed to see. So I have a question for you. Seeing the movies in a database is relatively trivial. What about seeing other people's passwords? Right? SQL databases are used a lot of the time. For most username password applications, the usernames and passwords are stored inside of an SQL database. Question?
So, is this like the guy who's entering input can do an SQL injection?
That is exactly what this is, yes. This is what's known as the SQL Injection Attack. So, it can get worse than this as well. Not only is it possible, if you can crack the system, to to see more data than you should be able to see, you can even perhaps perform modifications on the database itself. Because one of the characters that you can inject into one of these queries is the terminate line character, right? That allows you to start a new query, which can do anything, like literally anything. And an easy thing too, you can disregard the rest of the line, whatever it was, just by inserting 2 hyphen characters, which is the comment that's the comment character in SQL. So you can disregard everything else that the you know, the designer of the system wanted to go at the end, right? You can delete all of the stuff in the database. You can destroy the database itself, have them reconstitute it from backups or whatever, you know. And all of this, basically, unless you guard against it, pretty much any web form that you've ever used connects to a SQL database at one point or another. So, like, the points at which you can attempt SQL injection attacks are manifold, right? Basically anywhere, like, it's like, you know, sign up for our newsletter, you know, enter your email, SQL injection attack, you know? So, yeah. When user input is mixed into a query like this, applications become vulnerable to SQL injection attack. This occurs when the attacker injects their own SQL commands as a string that accidentally gets executed by the database. Again, you can see more data than is intended. You can trick login checks, gain access without knowing passwords. You can access data from other tables using join commands, and you can even sometimes be used to modify or delete data. Although, you know, instances where you would modify, like, we're kind of living in an age where information is power, right? One of my favorite examples of this that happened actually in recent years. There's a website, or it's a dating website for married people to commit adultery, right? Ashley Madison, I believe, is the name of the site. And they were subject to an SQL injection attack. So you might imagine that whether or not you're signed up for a website where the whole point of the website is infidelity, you might want to keep your name a secret, right? And if some attacker has found out that found your name on this website by using an SQL injection attack, basically you've got a list of, like, you know, a couple of 100,000 people that you can blackmail, you know? Yeah, so be careful who you give your information to on the internet. And it's not just small-time guys that get hit by this, although small-time guys get hit by this a lot. Because generally speaking, protecting against this type of stuff, computer and network security is like a whole subdiscipline inside of you know, computer science and software engineering. Computer security specialists make mad bank. Like, they're highly, highly in demand, but that's because it's a very difficult profession, right? Like, the high degree of expertise is required because, like, you have to keep up with the hackers if you're in that type of profession, right? But, you know, then there's basic stuff like, you know, don't make your system vulnerable to injection attacks. But and, you know, there are automated tools that you can get to, which you know, you run it and it attempts to perform injection attacks on your web forms and stuff, and you can see if it worked or not. But yeah, security is a big thing. The smaller you are, the less likely you have money for security experts.
The more likely you're getting.
Yeah, although the bigger the target, the more profitable it is to attack them as well. So some big guys that have been attacked in recent memory, Yahoo emails were breached, and, like, you know, I think they lost like 500,000 accounts or something. A few years ago, Health Canada, or Ontario, one of those, lost like all kinds of patient information. The PlayStation network was breached. That was a big one. Like, I think several million accounts were compromised, and, you know, this is why you should never, ever, ever store your credit card with anybody who wants to store your credit card information, you know? Because like, whenever you know, while it may be convenient for you to like store your credit card information with Nintendo or whoever it is, so that you don't have to enter it in every time you want to buy the new Mario or whatever. What you're doing is you're saying, "This is my credit card. I am placing it in your hands. Please keep care of it." And then you look out, and like a hacker looks out and is like, "Oh, so Nintendo probably has several million credit cards. You know, if I could crack that, then I've got several million credit cards." You know, and you know, credit cards these days will have fraud protection measures, and they'll reconstitute funds and that sort of thing. But let me tell you, it's still a hassle, you know? Like, it's still not something that you want to get involved with if you can avoid it. So that's why your professor never ever entrusts his credit card information to any company. There's a golden rule in computing, which is never ever ever trust a computer that you can't throw out a window. So we talked about that. We talked about that. This is the classic XKCD cartoon, wherein a mother sends her son to school, includes in his legal name an Sql Injection Attack, and compromises the school's permanent record database. As any of you read XKCD? No? Everybody should read it if you are, at all interested in science and math and anything. It's a good comic. I've been told that what they're teaching in like the engineering stream these days is that there are only two types of comics which may be legally included in a presentation. In their communications courses is what they're saying. One is Dilbert and the other is XKCD. And XKCD is generally funnier than Dilbert, but anyway. So, already talked about that. So, if these are such a vulnerability, how do we not get attacked? So, the conventional wisdom is to just not do anything strange and use the libraries as intended. The SQLite library, for example, includes this insertion, like basically you're trusting the execute command to perform the string insertion for you. When it does, it performs checks to make sure that this doesn't contain any illegal characters or anything that might indicate an SQL injection attack, right? Further, using the execute statement instead of the execute all statement also helps prevent the worst SQL injection attacks, because it's not that it only executes one statement, it's that it can't execute multiple statements, right? Multiple statement SQL injection attacks are like, sufficiently bad to be worried about, right? They can delete all of your data. If the thing that's interacting with the database is only expecting one and it gets two, it's like, nope. It just hard nopes on that and it just shuts it down, right? Which is another layer of protection. Yeah. Make sense? Any questions about any of that? Because we're pretty much done databases. Cool. All right. Yeah. Basically, you as the amateur programmer, and I include myself when I say that, you're not going to be able to reproduce all of the security mechanisms that are baked into these libraries yourself. Even if you were to reject queries yourself that contain quotes, it's like basically you're then having a fight with a hacker who's been doing this far longer than you and knows way more about programming than you do, right? Rather than match wits with the hackers yourself, rely on people who are better at it, basically. But yeah. Yeah.
There's a video on YouTube by Number File,
Mm-hmm.
I think, or it's Computer File, I don't know, in which he shows how it's performed
Yeah.
and how he does it. So maybe that can be interesting to some people.
I generally recommend all of my students to watch as many computer file videos as possible. There's also one on time zones that's funny. Yeah. Question?
You ever hack into something yourself?
I'm not a practitioner of the dark arts, no. This is Defense Against the Dark Arts, not dark arts class. No, I generally the place that I fit into the grand scheme of things with respect to programmers is I'm a grammarian. You know, my subject, my subject of expertise is the construction of compilers, right? And the construction of computing languages. So if you want to build a new language from scratch, come talk to me, right? But crypto and security and cryptography and all of that stuff, it's oh my God, go talk to an expert. I got enough to teach an intro course though. But yeah, no, I also know a bit about architecture, mainly from teaching courses, but like a really low architecture, like what a CPU actually is and does, you know. Because I teach mechatronics courses, which, you know, for them, it's not, what mechatronics is doing is it's actually designing custom purpose processors from electronic components alone. That's at least part of what they do. Because when you design a custom purpose processor, basically a CPU is total overkill for many applications, so you just design your own chip. And even though it costs more to design the chip than to, you know, use an Intel CPU, over time, if you if you do a production run of 1 million, then the cost can low enough that it's more effective. Yes?
So like an ASIC?
Yeah, ASICs, yeah. It's like a step up from an ASIC. ASICs can be anything from a few gates thrown together to something like this. It's a very umbrella term, but yeah. And that's something that you'll learn about if you change programs to the engineering program. There's no real courses on it in computer science that I'm aware of. There's a course on digital logic, I think, but you wouldn't go as far as custom purpose processors. But yeah. Yeah, you have to know what a register is and stuff like that. Anyway. Okay, so that's databases. Good, all cool stuff. We're going to talk about machine learning now. Where are we here? Slides. Go. No, stop. There we go. So, machine learning is a hot topic. It's it's one of those topics that's very likely it increases the probability of your paper being accepted if you've integrated machine learning somehow, right? It's, in my view, popular somewhat spuriously because a lot of people think that it's something it's not, right? We are not talking about generalized machine intelligence or artificial intelligence. What we are talking about is statistical analysis over large data sets, right? So this is not teaching the computer to know, right? This is statistical analysis with values that may change over time. The machine isn't learning, it's gradually developing a more and more accurate model of the thing that it's trying to model, but it's always modeling it mathematically, right? Now, you know, I don't know. People get all, you know, weird about AI and like, it's strange. I feel like people think that like the singularity is coming or has already happened or is like happening in the next 5 years or something, you know? You guys know what the singularity is? No? Okay. So it used to be science fiction, but you know, people have decided that science fiction is reality these days. Yeah?
Is it like the sentient? Like the AI taking in?
Yeah. So the idea of the singularity is that it's like, it's generally being observed, where's my chalk? It's been generally observed that like technology has been increasing exponentially, right? The idea is that like there is going to be a point at which technology just shoots up, straight up, right? And essentially off to infinity, right? In science fiction, the hypothetical reason this takes place is that you get, you know, at some point, general machine intelligence capable of generating the next generation of machine intelligence just up by itself, right? So it's like, you know, human beings take, you know, 5 years to develop the AI. Then the AI takes 5 minutes to generate the version 2 AI. Then that AI, being so much better than the first AI, takes 5 seconds to design generation 3 AI, and then, you know, you're off to the races. It's like new generations of AI are happening so quickly that, you know, basically, it, you know, whatever the physical limitation is on machine intelligence, it hits it, you know, within a week, right? This is the idea of the singularity, and it's like the machine will become so much more, you know, so much more intelligent than human beings, than, you know, that we're just going to be ants in comparison to the machine mind, right? Now, you know, like all bad science fiction, in my view, it's used primarily as a way of forwarding the author's particular political agenda by making the AI agree with whatever their preconceived political notions are. Personally, I think that if you knew, like, the problem with machine intelligence is that we would be unlikely to recognize it as such, right? Because, like, a machine being a very different thing than a human being, if you considered it to think, would think so differently from human beings that we wouldn't recognize it as thinking. That's like what I think about the whole thing. But at any rate, for whatever reason, we live in an era where people are convinced of the imminent arrival of advanced machine intelligence, and we're just going to talk about some statistics, which is not the science fiction that everybody's been talking about. That being said, machine learning is, like, although it's not, you know, although it's not the stuff of science fiction, there are still interesting and useful things you can do with machine learning, as presently constituted, as we'll see. But what this is statistical analysis. All right? So, good. Basically, it's like a combination of like existing statistical methodologies that have existed, you know, for like, you know, a couple of centuries, combined with like increases in the number of sensors and increases in the ability to acquire data. That's like it's really the data that's driving machine learning, not the statistical techniques. Those have been around forever, right? So, anyway, that rant out of the way. So, what is machine learning? Machine learning is a computer system whose performance on a particular task improves as it gains experience. What is meant by gaining experience is that the data set upon which the statistical analysis is being performed is increasing in size over time. So you come up with a, like if you were thinking of linear regression, for instance, the number of data points on which you are calculating the linear regression increases over time. Therefore, because you have a higher population size, the degree of fit to that population, you know, becomes more and more accurate to the sort of true trend of the data, right? It's the statistical effect of the larger population size primarily that makes it improve over time, right? You can also set systems up where, like, you know, you're throwing out a certain number of the old data points as new ones are being collected so that you have a sort of reflection of the state of things at the present time for things that are variable over time. That's another way that you can do it. So, alternatively, machine learning involves observing a set of examples, the training data, and then attempting to conclude something that generalizes that data. Many statistical methods are an example of machine learning. For example, linear regression. I assume all of you have studied linear regression and performed it plenty of times. Anybody not done linear regression? Okay. So
I might have done it, but I'm not like, I don't know the technical term.
Sure.
Maybe.
Well, we can review it in concept, right? So the idea with linear regression, right, is that you have a series of data points, right? You're trying to calculate a line through these data points that minimizes the square of the distance of those data points to the line, right? So you have like a distance here, right? A distance there. Whichever line forms the minimum of all of those distances squared and summed up, that's the line of linear regression, right? You can perform similar analyses. You can perform like, you know, quadratic regression as well, or parabolic regression. If you, you know, if you have, you know, a certain set of data points.
And
Yeah.
to check which is the parabola, which is
Yeah.
closest distance.
Yeah. And you know, you can, using these types of techniques, you can get like lines that look pretty, you know, squiggly. If you do like, you know, get power of 8 or something, you know, and often like these will go off sharply to, you know, bounds on the end outside of the range. So, you know, you don't want to rely on these, you know, you want to do like a linear projection or something off the end of it. But anyway, so that's the idea of regression. We're also going to do clustering analysis. So, in machine learning, there are generally two categories: supervised and unsupervised learning. In supervised learning, the computer is given a set of example inputs and the desired label or output for each of these inputs. This is called the training data. An example, which is sometimes done, you have image recognition software, right? it used to be like fluffy stuff like, can the computer tell apart a dog from a cat, right? These days, the applications are somewhat more pragmatic. Given an image of a street, is the stoplight red or green, right? Stuff like that. So what you do to create the training data is you write a program called CAPTCHA, which requires human beings to click on all of the little pictures that contain, for example, a stop sign or a taxi. That's the method by which you generate training data by distributing the task to all of the users of the internet. But essentially what you end up with is a bunch of pictures which are associated with tags, right? Like, these are all pictures of stop signs. These are all pictures of yield signs, etc. The goal is to come up with rules that map inputs to outputs that perform well even for outputs outside of the training data. So the idea is the computer derives some kind of mathematical equation which operates on pixel values, right? That successfully returns the correct result for the training data, and then it can hopefully be useful for data other than the training data as well. It might be like this particular hue of stoplight. Does that, is that hue unique? Does it ever occur in nature? If not, then it might be like the correct hue. The thing about machine learning, which is kind of cool, is that the human being does not necessarily have to come up with a hypothesis of what factor will, which the computer will use to pick out a stop sign, right? The computer uses statistical modeling to find, in the same way that a linear regression finds a equation which best accounts for all of these different data points, the computer will come up with some equation that best describes all of the labels, if that makes sense. Does that make sense? Am I making any sense? Yeah? Okay, well, at any rate, in unsupervised learning, the computer is given inputs without any labels, and the goal is to identify some structure or pattern in the data. Sometimes, often even, in unsupervised learning, the thing that you give the computer is a goal, right? If you're interested in this sort of thing, there's a YouTube channel called Code Bullet that will write little AI programs to play video games like Pac-Man. And it's like, rather than trying to associate data with labels, what it's doing is you give it a goal, you sort of say, these are the things that you're allowed to do, and it decides what order to do things in, does multiple trials, and then, from the successful trials, or most successful trials, uses those as a basis for the next generation of variation. It's kind of like, they call these genetic algorithms sometimes, because the idea is it's somewhat simulates the process of evolution. The individual values which control, the Pac-Man character, for example, come to a finer and finer approximation of, what an ideal Pac-Man game would be over time by producing a certain amount of random variation in the way that it approaches it, running those tests, taking the best ones, and using those as the basis for the next generation of variation, which is a reasonably effective method of going about it. The problem is it takes time to run all of those tests, especially if it's something more complicated than Pac-Man. So, applications of machine learning. Classification. Usually a type of supervised learning. the goal is to come up with a rule that classifies inputs based on the classes in the training data. So, again, you have a set of images. Tell me which of these are photos of dogs and which of these are photos of cats. Right? Classification. Regression is also a type of supervised training, or supervised learning. In regression, output values are continuous, i.e., for example, real numbers rather than discrete, as with classes or types. The goal is to come up with a rule that predicts the output values based on the values in the training data, and ideally, you would be able to project the trend beyond the scope of the existing data. Good. Any questions so far? We also have cluster analysis. Cluster analysis is a type of unsupervised learning. The goal is to take a set of inputs and divide them into groups. The groups are not known in advance. We want to essentially classify things based on similarity to other things. So in this particular set of points, this might be a clustering. Although there might be a certain amount of, there might be a certain amount of argument to be had as to whether this point belongs in that group or that group. Outliers are going to be a little bit tricky in all cases, but I think we can generally agree that this is a cluster, that's a cluster, that's a cluster with some outliers, right? Good. So, for example, in supervised learning, given a data set of feature vectors, each with some labeling, if we were given a new one, could we figure out what the classification is? So in this particular instance, we have a list of famous Americans and French people. We have their nationality indicated. We have their heights in centimeters also indicated. And we have some labels which are meaningless other than to be labels. So Abraham Lincoln, George Washington, and Charles de Gaulle all qualify as A, and Benjamin Harrison, James Madison, and Napoleon are all labeled B. The astute observer might already be able to pick out the trend. What's dictating the label here? Yeah. Height, obviously, yes. Nothing with a label B has greater than 170, and nothing with a label A has under, approximately 190. So, there you go. We have a theory, right? The thing that's, so if we had another one with that height, obviously we would label it A, right? The thing about a computer is that it approaches this problem atheoretically, right? It does not assume any of these factors have greater weight in determining it before it actually measures things, right? It doesn't go in with a priori assumptions. Human beings do, right? A human being looks at data and says, even if you're a very well-trained scientist, you're always going to look at data from a particular perspective or from with a particular result in mind, right? A good scientist does not, right? A good scientist looks at data as atheoretically and with as few prior as they can manage as a human being, right? However, one of the things about scientists is that they have to get papers published, right? Positive results publish better than negative results, right? And not to mention, if you've come up with a hypothesis And if you've spent years working towards that hypothesis being proven or disproven, you have a vested interest in the outcome of the experiment, right? The computer has no vested interests in anything by design and by construction. So, it could be that, we don't know what label means in this context. Label might mean to our researcher, was a fine, upstanding human being if they're A, and was an insolent cur if B, right? A computer would look at it and probably say, oh, no, it's just numerically derived from height primarily, especially considering there's no outliers in that data to mess things up. But a researcher, a human being, might not be so unbiased, right? Good. Human beings can be incredibly intelligent, far more intelligent than a computer, but, human beings always have their own inbuilt biases. So let's talk about clustering analysis. In unsupervised learning, feature vectors are given without any classification. Clustering is used to determine, to try to find clusters of similar feature vectors. But the question is, how do we measure similarity? What does similarity mean in this context, right? We know that, if things have the same nationality, if all these people have the same nationality, then that's similar, right? More similar than not, but are we looking at the number of syllables in last name? Is that, well, that could be a point of similarity, right? What does it mean to be similar? So, we will construct a numerical vector representing our features. We will then compute the distance between those vectors. So, what we do is we take this data, whether it's labeled numerically or whether it's got, American, French labels, alphabetic information, shall we say. We convert it to numbers or Booleans. So consider the following data set. We have a set of animal names and we have a set of animal features, right? Features being egg-laying, scale-having, poison-having, cold blood-having, number of legs, and whether or not it's a reptile. For the purposes of this demonstration, we will consider whether or not it's a reptile to be the label that we are applying to these data points. For example, dart frogs lay eggs, do not have scales, are poisonous, are not cold-blooded, have 4 limbs, and are not a reptile. So, I just want to point one thing out about this data set before we get into it. When you're doing data like this, any weight, the maximum range of variability of the feature that you're talking about will have a skewing effect on the data. So in this particular instance, number of legs ranges from 0 to 4. You will find later on that we will model false as 0 and true as 1. That means that the number of legs will have 4 times the impact on the numerical analysis of any other feature. If this is desirable, fine. But typically it won't be. Typically, when you have all of these features, you want to not assume that one is more important than the other. Importance is degree of variance here. So what you would do is you would normalize this typically you normalize it so that the maximum value of any of these will be 1, right? So if you have a bipedal organism on the list, such as a human being, you would, you would have So, good. So we first convert each animal into a sequence of numbers. If we set true equal to 1 and false equal to 0, we get the following feature vectors for a few of our animals. Now we have a bunch of features and we have to decide how far apart they are. Normally, when we want to measure the distance between 2 points in space, because that's what a vector is a point in space. Normally what we do is we use Euclidean geometry. We assume that the shortest distance between 2 points is a straight line. With clustering analysis, we use what is called the Minkowski distance. The Minkowski distance is essentially, it's also called Taxicab Metric. So the idea is, if you've restricted the paths that can be followed and disallowed diagonals, right, then each of these three lines, the red line, the blue line, and the yellow line, are of the same distance, right? They each travel the same horizontal and vertical distance, right? Despite the fact that one is a closer approximation of the diagonal line than the others, right? So the Minkowski distance then is just simply the sum of the absolute values of the differences between the individual features. Make sense? Any questions? So, here's a two-dimensional example. What is the taxicab distance between V1 and V2, where V1 is 2,2 and V2 is 6,5? Seven, yes. Distance here is 4, distance here is 3, 4 plus 3 is 7. Thank you. So, good. And of course, Euclidean geometry, if you were to, if you remember back to our Pythagorean triangles, if you have 4, 3, the hypotenuse will be 5. Fine. Sure. So, we can express this as a function in Python. The distance is the sum of the absolute values of v1 at I minus v2 at I to the power of p for I in range length of vi. And then we return that to the power of 1 over p. So that's, that's throwing that square factor in there. So, if we were to model our animals as classes in Python, def init self, name, and features. Note that name is not included in features, right? Self.name, self.features is equal to name and features respectively. And distance is the Minkowski difference distance between self.features and other dot features. Good. Question?
What were the inputs for the, what's P here? Oh, the power, yeah, okay. Okay, got it.
Yeah.
Yeah. Okay.
It's, yeah. Basically, you can take this and you can turn it into Euclidean distance by changing the power to 2, right? But if you leave the power as 1, then you're talking about the taxicab metric. So it's like an option there. Good. So, if we created a set of objects using our animal class, giving names and feature vectors, we can then collect those up into a list and effectively have reproduced the table. Then, yes, question?
So, like in the table, in the legs column, it shows like 4 and 0, right? So will the 4 be, like you said, it would be taken as 4 times the power of the Boolean random?
Well,
or will it be taken as true, just true?
no, in this case, we're not converting that numerically. We're going to, at least as it's done in the slides, 0 and 4 will be left. And we're going to see the effect of that. So, if we, this is very small, so I apologize, but if we then compare the Minkowski distance between all of the different animals in the list, we get the following, right? So, according to the data as modeled, there is 0 difference between a rattlesnake and a cobra, right? However, there is 4.24 degree, amount of distance between a cobra and an alligator. Now, the 4 there is coming from the fact that the alligator has 4 legs and the cobra has 0. If you'll notice, alligator has a distance of 4 from everything, aside from the dart frog, which also has 4 legs. Right, and you'll notice that the dart frog has a distance of more than 4 from everything except, the alligator, obviously. So, there you go. So, we would consider these to be outliers, right? For that reason. However, if you'll notice, these 2 outliers are less closely related to each other than most other things on the list, right? Like, for example, a python and a salmon have more in common than an alligator and a dart frog, according to this, right? Of course, yeah, it's not, basically, according to this list, the only difference between a python and an alligator is, the only difference between a python and a salmon is the fact that one's a reptile and the other is not, despite the fact that the organisms are quite different if you were to find them, in a zoo. But yeah, does that make sense?
Yeah.
Good. So, using this type of analysis, we can determine which of these guys are closest to which other guys. Basically, by scanning through this table and finding the points closest to each of the other points, right, we can sort of grow a set of elements which are considered in a particular cluster, and from there easily derive the clustering analysis. Make sense? Good. So, let's talk about linear regression. So, again, a lot of you have probably, well, at least 4 of the 5 of you in this room have done regression analysis at some point. What this example seeks to illustrate is not so much the process of linear regression as the process of how you might generate and tabulate and separate data for the purpose of performing a machine learning analysis. So the process that's being used here to work with the data will be similar to other supervised learning processes. All you would do is swap out the means of analysis that you're using for something more complicated if you want that. So, linear regression is a style of supervised learning. In regression, output values are continuous, i.e. real numbers, rather than discrete with classes. Our goal is to come up with a rule that predicts the output values based on the values in the training data. In this case, the training data will be that data which is used to calculate the line of regression, and the testing data will be that data which is used to verify that the line of regression is an accurate reflection of the data. So, there you go, line of regression. So, supposing we have two-dimensional data points, as so, we want to find a function f that predicts y from x. By the way, if you're working in multiple dimensions, higher dimensional space, it is completely, totally accurate and valid to, for example, come up with a plane in three-dimensional space which models three-dimensional points, or a volume in three-dimensional space which models four-dimensional points, or a four-dimensional hypercube in four-dimensional space that models five-dimensional data. The one, like, we run out of geometric analogies pretty quickly. Like, you'll notice that the feature vectors from the clustering analysis, how many do we have? We had 6 dimensions, which is more dimensions than you can visualize. So there you go. That's what the power of abstract mathematics is. You don't necessarily need to visualize 6-dimensional geometry. But anyway, so under linear regression, what we are trying to do is find the equation of a line which best fits the data. We have 2 parameters to work with. We have y equals cx plus b, so c, which is the coefficient, is one of the parameters that we get to decide the value of, and b, the intercept, is the other one. Between these 2 points, we can completely define the line. So, this is the procedure. Number 1, you obtain the data from whatever source the data is coming from. Number 2, you divide the data into 2 sets, the training set and the testing set. You run a linear regression on the training data to get the proposed coefficient and intercept. You use the proposed coefficient and intercept to predict the y values of the testing set from its x values, and then you measure the distance between the predicted y values and the real y values. So, essentially, you will use the data to obtain some kind of regression line. You will have a point, right, that you're trying to see if it fits that line, right? Essentially, you measure that distance, right? You do that for all of the points. That gives you some idea of how well the fit. Basically, it's the same thing as regression, but in reverse, right? Rather than starting with data points and finding the line, you start with the line and find where the data points should be, finding the fit that way, right? Good. So, measuring how far the predicted y values are from the real y values. Basically, the way that you want to do this is you want to do it in such a way that it doesn't matter whether the value that you're predicting is above or below, right? So you want to take the absolute value, yeah. In one way, well, you want to perform a mathematical function that results in that negative being blown out, but you don't necessarily need to know like the average distance. So you can just take the square, sum them, and then be done with it. So what's generally done is the mean squared error. So you have real and predicted y values. The error of each sample is the distance between the predicted and real y values. The squared error is the square of that term. And the mean squared error is, of course, the average of all of the squared errors for all of the samples. The other advantage you have from using the square rather than the linear distance is that the further, like the greater the error is, the more pull it has on the average, right? So basically, mean squared error punishes much harder for outliers than linear would.
Oh, because the error is double, or like it's error times error.
Mm-hmm.
So the error is like multiplied more.
Yeah, so like if I've got 1 unit here and 2 units of distance there, right? Then under like just the average distance, right? I would have 1.5, right? But if it were the square, right, then I would have 1 plus 4 over 2, which is 2.5, right?
Yeah.
So it punishes harder for outliers.
Good.
And, you know, if you had something that was like crazy, like 10, like that would overwhelmingly
Yeah.
dominate. And like, frankly, if this were the regression, you know, probably the line should look something more like that, right? That should be pulling up the slope. In essence, like what this is a measure of is how representative is the testing data of the, or how representative is the training data of the testing data, right?
How close it matches it.
Mm-hmm. You shouldn't really run into problems with this unless you don't have enough points that you're working with,
Okay.
right? Which, you know, it's kind of an open question, how many data points is enough data points? You know, this is one way of figuring it out. So, linear regression tries to minimize, trying to find proposed coefficients and intercepts that minimize the mean squared error. This is called least squares estimation. The coefficient of determination, aka R-squared score, is a measure of the, quote, goodness of fit of the regression model. So if you have an R-squared score of 1, that implies a perfect fit with the data. That is to say, each data point lies on the regression line.
Okay.
If you have an R-squared value of 0, it implies no better fit than a horizontal line, which, you know, if your data is sufficiently bad, that might be the case. Incidentally, you all know the iron law of statistics. Correlation does not imply causation. Have you guys heard that one before?
No.
Yeah? No? I'll explain it briefly. So, let's say you had two pieces of data that you were measuring. Let's say population of rabbits and tendency of a riding to vote NDP, something like that. It might be possible for you to measure data that suggests that the population of rabbits has an impact on whether or not people vote NDP, right? But correlation does not imply causation. That does not mean that a higher population of rabbits is causing people to vote NDP,
Okay.
right? What could be the case is, you know, there could be some third factor which is causing both of them
To be linked.
but you can't necessarily get to, you know, rabbits cause people to vote NDP.
Yeah, you
Right.
can't like put it as a fact
Yeah,
of saying that because of this, this is happening.
Exactly. It could be that, rabbits tend to live in like more woodland areas, which implies being in the country, which actually would imply voting conservative. So, whatever. But, like you can't just say rabbits cause people to vote a certain way, right? That's correlation does not imply causation.
Good.
And that's when you're watching the news, try to watch for how many times they use that one. They use correlation to imply causation. It's a lot more frequently than you might think, Like, if there's one thing that, everybody in this generation should be aware of, it's, the dishonest use of statistics, Always ask what the population size is of the study or the survey. Always ask, are they confusing causation and correlation? And, the other thing is, when all you've got is a correlation relationship, you don't necessarily know, even if there is causation, you don't know which one is causing the other, right?
Yeah.
It's like, are rabbits causing people to vote NDP, or is people voting NDP causing the rabbits? You can't actually determine from the statistical information, right? And the other thing to be aware of is biased samples. You might have, a huge sample, right? But if you've only tested, one specific type of person, for example, if the only people that you tested were people who already voted NDP, and there was no conservatives in the data set, then you don't know whether, you can't make any determination on whether bunny rabbits cause people to vote one way or the other, And I picked an intentionally ludicrous thing, But anyway, statistics. You guys take a statistics class, I'm sure, eh? What programs are you guys in? Remind me.
I'm in engineering.
You're in engineering, yeah. So you're taking it in third year.
No, I'm taking it in the first year.
The statistics?
No, not statistics. Oh, statistics at third year.
Yeah, statistics in third year. You guys are in sciences? Sciences, yeah. How early do they give you your statistics course? I assume you guys get a statistics course. Yeah. Yeah?
I took it in second year.
Second year?
Yeah.
Second year? Yeah. I'm sure they went over all this stuff with you in second year then, yeah. Yeah, one of the things that really burns my butt is the lack of mathematical literacy in society right now. It's people have no idea what numbers mean, It's amazing. But, anyway. Yeah, let's just call it for today. We'll resume this tomorrow, okay? I'm calling class 5 minutes early because, Any questions? No? Okay, good. Thank you all for coming today.